And my research will mostly be, well, it'll be all theoretical, which is different from pretty much everyone we've seen. There's some experimental component out in the field, so my work will just involve mostly just computers that I really like that, so that suits me. So first I just wanted to explain what a food web is, kind of the basis of what I'll be looking at. A food web describes all the species in an ecosystem, but most importantly, it includes the relationships between them. As with all research, the most important thing is your question. So my initial question was, how will climate change affect food webs? Which is really broad, so what will I actually be looking at? So in terms of climate change, what I'll be looking at is not just increased mean temperature, which is what most people think of when you think of climate change in the future, but also heat waves, which are set to increase in frequency. And this has really important effects on organisms because they have certain thresholds and whatnot physiologically. And in terms of food webs, I am interested in agricultural systems because lately there's been a lot of focus on the sustainability of conventional agriculture, which mostly relies on low crop complexity, so monocultures, and I'm interested in how that played into things. And then in terms of any other effects I should look at, I'll be looking at geographic location, so where these ecosystems, where the systems are actually located. Because you can imagine if they're, say, close to a large water body, that'll have a moderating effect on temperature, which will affect the food webs differently in those systems. So my new question, after considering all those extra factors, was how will climate change, specifically heat waves, affect agricultural food webs, and will this change with varying crop complexity and geographic location? Okay, so my approach will involve modeling the food webs, and they'll include crops, the insect herbivores that feed on the crops, and then predators that feed on the herbivores. And I'll be modeling how they all interact, so their population dynamics within the community. And to do this, I'll be using nonlinear differential equations, math, so don't need to go into that. So in these models, I'll be using a factorial design of treatment. So these are the ranges for each factor. I already kind of talked about this, but my models will vary from monoculture to polyculture, and they'll vary from, so the mean temperature, like I mentioned, from no change to the highest projected change. So I'll be using data from really complex climate models that predict future temperatures, like into the next several decades. So I'll be taking values for temperature from that. And then also the frequency of heat waves. And this isn't quite as, or there aren't as many predictions on frequency of heat waves as there are, just plain temperature increases. So the heat wave frequency I'll be varying myself just on set ranges and pretty much just kind of do it a lot and then see what happens with that. And then there will be low to high variance of temperature, which will be imposed by geographic location. So like I talked about before, proximity to a water body. So if you're really close to a water body, there will be low variance because there's a moderating effect of the water. If they're far away, there will be high variance. So how it'll actually work is I'll be setting up many models, and each will have a different combination of starting values of all these factors, so every combination will be accounted for. And then I'll run the models over several decades, like I said, and basically just see what happens, and look at how important each of these factors is. So for measuring the actual impact on these systems, to answer my question, question. I'll look at mainly crop yield, and I'll look at it in terms of mean crop yield and variance. And these are really important economically for farmers that grow the crops. And then I'll also be looking at resilience, which is how long it takes for the ecosystem to recover after disturbance. The disturbance in this case being the increasing temperature and heat waves. And this is really important for that long-term sustainability, which is what I'm really interested in these systems. So yeah, just to reiterate, the conclusions that I hope to draw by the end of the project will be how climate change impacts resilience and crop yield, and how it's affected by species diversity and geographic location. And in terms of problems that I anticipate, because this is just the start, what I plan to do, I'm always trying to think about what kind of problems might come up. It's very common to have models that you think look great, like I think I've set it up kind of well. That's why I picked this design. But a lot of times you end up having to change your models so drastically that they don't resemble the first one. But I'm looking forward to learning from that. And yeah, really cool project for me. So I hope you guys think the same.
Thank you.